Good morning, students. Today let's revise one of our topic, derivation of equation of motion graphically. Here graphically means by following the graph we have to derive equation of motion, and that equation of motion is used in whole universe to calculate velocity, acceleration, time taken, many things. So let's start. I have shown you the graph OT, that is it x-axis represent time. X-axis represent time. Again I am repeating, why only x-axis represent time? Why not y-axis? X-axis is an independent variable. It consists independent variable. Y-axis dependent variable. So time is independent variable. X-axis shows time. Y-axis here we are showing velocity. So I have drawn one velocity time graph. A body is starting from point A and it starts moving. As it starts moving, time is also passing, and it moves and comes at rest, reaches its final position, that is B. So here AB the body covers. The slope is AB. Its slope is AB. And slope of the velocity time graph is nothing but acceleration. So this slope AB, we have to find out the relation with the AB from x-axis as well as y-axis. So as we have to find relation with x-axis, I have just dropped one perpendicular on the x-axis, see here, that is BC. And to find the relation with y-axis, I have just drawn BE as well as AD. Perpendicular drawn on y-axis, that is on the velocity. So you have got here BC. One perpendicular, and again on this y-axis I have dropped one perpendicular AD and BE on velocity axis. So what we have got from this? We have got OA is parallel to CD, which represent the initial velocity U. OA parallel to CD and it represents initial velocity U. BC is parallel to OE. BC is parallel to OE and it represents final velocity V. OC, this is OC parallel to AD and this is parallel to BE and it represents time T. So here what is then BD? BD, this we can find out as BD. We know BC first. Take out BC. BC. BC total. So BD is BC minus CD. We can write easily. BD is BC minus CD. So I hope this is the basic fact from this graph you have understood. So let's start from deriving equation of motion. So first equation of motion, V is equal to U plus AT. Leave that. We don't know anything. Don't think about that, what we have to do. Simply we know that the body is starting with some initial velocity u After certain time t, it reaches its final velocity v with acceleration a. Acceleration a. So from this total, simply what we have got? AB. Slope of the graph AB. Slope is equal to AB and AB is equal to acceleration A. We know what is acceleration? Simply rate of change in velocity. You know students, change in velocity by time rate is nothing but time. So we can write it as change in velocity, that is final velocity minus initial velocity by time. But we are deriving graphically, so direct we cannot write this one. So here you see, from the graph AOA, that is ABD, from the triangle ABD, this is hypotenuse AB. We can write this hypotenuse as AB is equal to BD by AD. BD by AD. Then what is BD? Just now we have find out BC minus CD. So we can write BC minus CD by AD is parallel to OC. So directly I am writing OC. AD is parallel to OC. Then what is BC? Find out. BC is V, final velocity V, minus CD is U, initial velocity U, by OC is time t. So we can write t. And AB is the slope which represent acceleration. So we can write this as AT is equal to V minus U. So take out V, it implies that V is equal to U plus AT. So first equation of motion derived graphically. This is first equation of motion. Let's see the second equation of motion. Second equation of motion is S is equal to ut plus half at square. Again, don't think about anything. Only think from where the body is starting and final position where it is reaching, what we have got it. So here the body starts from O, A, B and C. This full area the body is moving, because S is the distance. How you find out the distance? If I'll say you that enter in my home and cover all the distance, then how will you, from where you will start, where you will end? If you are starting from entrance, then you have to come in first room, then you have to go in kitchen, then bathroom, then again in another room, then if you have a courtyard, you have to go courtyard. So from where you will start and where you will go, it's so much confusing. So it's better if you will go at the roof and just go on the boundary. That means you are covering the whole distance. If you are covering the whole distance, that means that total area is only the distance covered. Here also same thing is happening. A body is starting from position A and finally reaching at B and with reference point O. So body is covering the trapezium, that is area of trapezium O, A, B, C. O, A, B, C. This area the body is covering. So in this area you are getting two things. One, the triangle, that is A, B, D. So we can write this as distance covered. This distance covered is the area of the triangle. Area of triangle ABD plus area of rectangle OADC. Area of rectangle, use rectangle OADC. Say this. Very easily now you can find both the area and we can find out, derive the equation. So area of triangle ABD, you know area of triangle half base is AD, directly I am writing AD into altitude is BD plus what is the area of rectangle OADC? Area of rectangle is length into breadth. Length is OC and breadth is OA. So directly we can write it as OC into OA. So here half AD into what is BD? We have find out BC minus CD. So here I can write BC minus CD plus. What is OC? OC is time T and what is OA? U. So directly I am writing U into T. Here just derive it half. What is AD? AD is parallel to OC. That is we can write T into what is BC? BC is nothing but velocity V minus what is CD? CD is parallel to OA, that is U. So directly I am writing U plus UT. So here half into T into what is the first equation of motion? Just now we have derived it, that is V is equal to U plus AT. Put the value of V from first equation of motion minus U plus UT. This U and U cancelled. So here we can write this as UT plus half AT square. T into T square. So we have got S is equal to UT plus half AT square. So your second equation of motion derived graphically. Your second equation of motion derived graphically. Let's see the third equation of motion. We know that the third equation of motion is V square minus U square is equal to 2AS. Just now before this we have started from S. So again let's start from S. Easily you can understood. S is the distance travelled by the body in whole of its motion from initial position to final position. So thus see S is nothing but the area of trapezium OABC. Area of trapezium, students, you are knowing that is its formula is half into sum of the parallel sides into distance between them. Distance, or you can say height between them, or distance between them. So here what we are saying half. What is the sum of parallel side? Sum of parallel side is OA plus BC. It's BC into distance between them. Distance between the sum of the parallel sides, and that is nothing but AD. So here you will see half OA. OA is what? U plus what is BC? BC is V into AD is parallel to OC, that is time T. This we have to replace the T because in third equation of motion we don't need the time. So first equation of motion V is equal to U plus AT. From here you take out the T. T is equal to V minus U by A. Write the formula of T in this equation. We will get this half U plus V into V minus U by A. Just see v minus u by a. So directly I am writing half u plus v plus u and v minus u by a. So we can get a plus b into a minus b. So what you have got? S is equal to half 2a v square minus u square. So this cross multiplied 2as is equal to v square minus u square. So we have got the third equation of motion. Like this, graphically we can derive the third equation of motion, and it's very important. So students, you go through, practice it and prepare for your exam. Okay.